What time is it? It's science time!
Science time. Let's all stop and just unwind. 1, 2, 3, 4, here we go. Learn so much your brain explodes. Lessons so cool, so fresh. Beat so big you'll lose your breath. Learning facts and real cool stuff. Scream for more, can't get enough. It's science time. It's fun, you best believe. Explore and learn new things. Come and join me, please.
I'm Mr. C, and this super smart group is my science crew. Lila is our notebook navigator, Alfred is our experiment expert, Riley is our dynamite demonstrator, and London is our research wrangler. Working with my team is the best and makes learning so much fun. Actually, you should join us. We're learning about polymers. What time is it? It's science time! Welcome to DIY Science Time. I'm Mr. C, and I'm so glad you're here to be part of our crew today. We're talking polymers, and I have a polymer right here that's sort of anti-gravity goo. Let's check it out. Isn't that cool? I can actually tip my cup upwards, and it pulls it out of the cup. That is amazing. And you might be saying, what is going on with this? Well, let's talk about what it really is. It's a polymer. This goo is a polymer. This bouncy ball is a polymer, and this cafeteria tray is a polymer. Although they look different, they're all polymers. Polymers are just a big long chain of molecules. Poly stands for many, so we have many molecules linked together here. Each of our polymers on the table, they're very similarly linked, but the way they're connected is slightly different. Our slime is linked, but it's not linked super tightly. So that allows our slime, our goo, to move around pretty easily. Our bouncy ball has more links in it. That means it's going to move a little bit, not as much, and give it that elasticity, that bounce. And our last one, this cafeteria tray, it's hard plastic. This polymer, look at this, it's linked really, really tightly. And basically, it gives you the idea that it doesn't have as much flexibility. Yeah, so these are 3 types of polymers here on the table, but the question is would you like to make a polymer of your own? I think we should make some slime together. Alfred, let them know what we need today for our materials.
It's not a stretch to say this activity is going to be fun. You'll need the following materials to create your slime: glue, baking soda, contact solution, measuring spoons, and don't forget your handy dandy science notebook.
A science notebook is a tool that every scientist should have, and it gives us a place to record all of our learning. Taking good notes and being organized allows us to be better scientists. A science notebook allows us to go back and review all the data and information we've gathered during our experiments. Plus, it allows us to share results with other scientists who might be interested in learning more about what we've discovered. Whenever you see the notebook pop up on the screen, like this, it's a reminder that this is a good place for us to jot down new information. You can see I've already added a title and a list of materials for today's activity. Our crew is still going to have lots of information to collect and organize as we go through the experiment, so keep your notebook handy. Most importantly, the more you use the science notebook, the better you'll get at taking notes and recording data. If you don't have a science notebook yet, download a copy of Mr. C's science notebook from the website.
Glue is one of those polymers that we use all the time, and it's really handy to have around the house. Sometimes you're crafting and having fun, and other times you break something and you might need to repair it. But glue is constructed specifically to be flexible and move around. Just like those links we were looking at earlier, those glue molecules, those polymers just can bend and flow over each other. But here's the thing, glue by itself is not slime, it's glue. And in order for glue to become slime, we need an activator. This contact solution is going to take those molecules and link them together so that it's more firm and keeps it from just flowing, but gives us that slime texture that we're all familiar with. So let's make our recipe and let's have some fun making slime. Slime.
Slime!
And the cool thing about a recipe is When we use a recipe, we can replicate it over and over and over and over again. And that's what scientists do. They have a recipe or a formula to make something so that they can replicate it in the future. So for us to get started, we're gonna need 8 ounces of glue. Oh, that's heavy. There we go. Pour that into a cup. Now we're going to also add a half a tablespoon of baking soda. Gonna stir that up. And if you want to add color to your slime, this is the step where you would want to do that. Oh, I've got blue fingers already. Mix that up nicely. And you can see it's just blue glue. Nothing fancy yet. And that's because we haven't added our activator, the piece that's going to link all of those polymers together to make slime. Now our recipe calls for 1.5 tablespoons of contact solution, but I always like to start with less. So I'm just going to start with 1 tablespoon of contact solution first. Pour that in. And now when you start stirring it, it instantly starts to glob up. Oh man, it's already turning into awesomeness. Now, if it's really sticky, mine's still pretty sticky, you can add a little bit of that contact solution in at a time. I'm actually gonna pull mine out first, maybe. Oh, this is where your hands get messy. Oh. Look at that. It's actually really a good consistency already. If it's feeling sticky, you're gonna add just a little bit more contact solution to it. Now we have about a half a tablespoon left, but I'm going to just take my contact solution and just put a few little dribbles on it. This contact solution is going to make those polymers, the glue molecules, stick together better. And soon we'll have the perfect consistency. Look at that. That is awesome. Slime. Oh, I think you should try this recipe also. Polymers are made of long repeating chains of molecules. Some polymers like rubber bend and stretch, while others like plastic can be hard and tough. While we have our slime, I figured it'd be really cool to show you something really interesting with this elastic liquid. We're gonna take 3 colors and put it into our bowl. And we're gonna let them sit there and settle just for a second. And now I need to insert my glass rod into my drill. And then we're going to take this and put it right in the center and spin. That is so amazing. Whoa, look at that. Did you see the slime crawl up the glass rod? This is because of the Weissenberg Effect. There was an Austrian physicist, Carl Weissenberg, who determined that this happens when elastic liquids are squeezed together. Now we can actually see this ourselves if we just take the slime we have and you squeeze it. What happens is, this is a non-Newtonian fluid. Slime wants to behave like a solid sometimes, and it wants to behave like a liquid sometimes. But what's interesting, when you squeeze it, when you apply the pressure on the outside, the slime goes up. And if that rod was here, it would actually move up the rod. As we're spinning it, we're causing the slime to grab onto itself over and over and over again. And this causes it to push itself right up that glass rod. I think we should definitely try that again with some different colors. Don't you think? Let's do all the colors. That is so cool. Look at it. That is awesome. The Weissenberg Effect.
Want to take your slime to another level? Mix 2/3 cup of white glue and 1/4 cup water. Then add in 1/2 teaspoon baking soda and 2 to 3 cups of shaving cream. If you want, this is when you can add a few drops of your favorite food coloring. Mix all of these ingredients together really well. Then add in 1.5 tablespoons of contact solution. Now it's time to play with some soft, stretchy super slime.
Are you ready to follow that water? Keep your eye on this H2O so you know where it goes. So we know where the water's at. So let's mix it up just a little bit to confuse all of you. Do you guys know where it's at? Do you know where I have the water? All right, if you think it's in this cup, you are incorrect. No water here. Well, little bitty drops of water, but no water. Let's turn that upside down. All right, which cup do you think it's in? Which cup? Cup 2 or cup 3? If you think it's this one, no water. And if you think it's this one, no water. So where did the water go? It's not a magic trick, it is a science trick. Look at that. This is a super absorbent polymer. This is sodium polyacrylate. And this here absorbs 800 to 1,000 times its weight in water. But other than a science trick, what can we actually use this for?
I'm glad you asked. Disposable diapers, like the ones you find in stores today, were invented in the 1950s. The bottoms of the diapers have pieces of super absorbent polymers mixed into the cottony layers. These small polymer pieces can absorb lots and lots of moisture, like a turbocharged sponge. Some super polymers can absorb up to 800 times their weight in water. That's going to make for a lot of happy babies and dry tushies. We've already absorbed so much great new information today. Making slime is so much fun, and I have to say, the Weissenberg Effect is one of the coolest things I've seen. I wrote down our recipes and made notes for some of the changes we tried. My favorite is the fluffy slime. Do you have any fun ideas you can try to change the recipe and create your own version of slime? Always be sure to jot down those ideas in your notebook.
Thanks, Lila. Grab a plastic sandwich bag. The Fill it up halfway with water and snap it closed. Take a few sharpened pencils and carefully push the pencils straight through the bag. The water doesn't leak out. That's because the bag is made of polymers, and those molecule chains are flexible. Those flexible chains wrap around the sides of the pencil to create the watertight seal. This makes the water stay inside and keeps you dry.
So we made some slime, and we talked about how those polymers are linked together, but let's make a bouncy ball, something that actually can bounce. That was cool. All right, for this you're gonna need a couple of things. Some glue, some cornstarch, some water, and some borax. Let's get started with our borax solution. First thing, we're gonna need a cup of water, half a cup, 2 halves make a whole, and then we're gonna add 2 tablespoons of borax and mix it in. While that's dissolving, we're going to set up our glue and our cornstarch mixtures so that we can put it in there. For each bowl, we're going to add 2 tablespoons of glue. Well, about 2 tablespoons of glue. And then we're going to add 1 tablespoon of cornstarch. So this is a half a tablespoon. 1 half, 1 half, another half gives us a whole. And if you want to add color to your bouncy ball, this is the step you want to do it at. I'm gonna go blue, green, and yellow, and I'm gonna add a lot of blue because I want my colors to be really vibrant. All right, so I made a little bit of a mess. Before we start dipping all this in here, I'm just gonna clean up my cornstarch and this little bit of food coloring so that I have a nice clean space to work with. Now we're going to take some of our glue and put it into our borax solution bath. Now I made a lot of glue. I'm not gonna use it all, but I'm gonna pour some in, just string it in there, and that way the borax is touching lots of the glue. And the borax is the activator. It's what's causing those glue molecules to link together. And I'm going to take a fork. I'm just gonna kind of poke at it a little bit. Toss it upside down. We're gonna let it sit in there for about 15-20 seconds. And you can see sometimes there are these like packets and pockets of glue. I'm gonna squeeze it and then just put it back in to let it bath a few more seconds. All right, take that one out. There's our blue. Let's go for green. Looks like a worm. That looks awesome. And once again, I've got this really big chunky part here. I'm just gonna squeeze that. Put it back in there, let it soak. And we're gonna take that out, set it down. Oh, it doesn't look like a bouncy ball yet, but it will. We're gonna take our yellow, pour it in. It's almost orange. Oops, I got some green mixed in with it. I'm gonna pull this packet out, I'm gonna squeeze it, and you can see there's a lot of glue still that hasn't linked. Put that back in. And now we're gonna take that out. So we have all three colors, and you could mix them all together and it would be a huge bouncy ball, or you can make small parts to have a smaller bouncy ball. I'm going to take about half of each so I can make 2 bouncy balls. And then I'm just going to literally put them in my hand and start squeezing it together. And look at the pattern we already have. That looks so awesome. I'm gonna roll it up. And I'm gonna put it back into the borax solution bath. And I'm gonna take this one, smash it together. Oh, it's so gooey. It feels like slime, but it actually is more firm. You can feel it's more rubbery, like a bouncy ball. It has a different texture. It doesn't stretch quite like slime. And we don't want it to, right? We want this to bounce. And we're gonna put this back into our solution, and we're just gonna let it roll around and sit in there for about 3 or 4 minutes. And while that is taking its bath, I'm gonna clean up again and wash my hands so that when we take this out, we can play with it. All right, cleanup time. So let's take this out and see if it actually bounces. Ooh, it's definitely slimy. See what it does? It bounces. I wouldn't say it bounces really, really well. All right, that one bounces pretty well. Ah! It is super slippery. All right, here we go. They actually bounce really well. I'm really impressed with these. So you can, you can actually hold them and drop them off from the same height. And it looks like the bigger one bounced a little bit more. Here's my recommendation though. You let them sit, you let them dry now. Okay, you just let them sit, you let them dry, and eventually, like the one we had earlier when we started, this one is dry, and it actually has a little more bounce to it because it's gonna firm up. And what's really neat, if you want to, that's so cool. I also took a piece of it earlier and I put it into my measuring spoons and I let it sit in there so that it became nice and shiny, and it's really smooth and it's pretty firm. So now, let's see what happens. That one bounces really well. And I'm gonna attribute some of that to the shape, right? Because it's actually more spherical than it is that shape or this shape. And I think the more spherical it is, the better bounce it's gonna have. So let's try that again. Nice, that's actually that's awesome. That one bounces pretty good. Here's the one we just made. All right, they're working. So you make your own bouncy balls with the materials at your house, and then you can have all sorts of fun like this. This is so much fun. I should make a jumbo one.
Norman Stingley invented bouncy balls in 1966. Bouncy balls are made from another type of polymer, elastic rubber. The rubber ball launches back up into the sky when bounced against hard surfaces. How high can you bounce your bouncy ball?
Artificial snow is another polymer that you may have seen before. Artificial snow is similar to the polymer in a diaper, but it's designed to be fluffy and soft instead of gooey gel. Mr. C is using artificial snow and food coloring to make some very colorful snow. Once he adds water, the snow expands so much that it pushes up and out of the cups. Beautiful polymers.
That is amazing.
Let's bounce back into our notebook, add a few pieces before we wrap up the day. Polymers are so helpful. They help babies stay dry, keep our cars driving on the road, and give us fun toys to play with. I wonder what other amazing things could be made from polymers. Maybe create a bouncy pen? Now that could really put a spring in our notes.
A bouncy notebook? Now that could be an invention that could be a lot of fun while you're trying to take notes. Speaking of notes, if you don't already have a notebook, hop online and download a copy for yourself so that you can take notes, record your research, and record all of the data from the experiments that you're conducting at home. Things like polymers are so much fun. We've talked anti-gravity goo, we've talked slime, and we've talked bouncy balls. But most importantly, we've talked about how these molecules are linked together. Hey, that's like us. We're linked together. You're part of our crew. You're one of the links on this molecule chain that we have. Oh, how cool is that to think about? Keep learning, keep having fun, keep exploring, and remember, science is wherever you are. See ya.
It's science time. 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 It's so much fun. Learning fun for everyone. Everyone. It's science time.
And now I
Yes,
have to
yeah,
pick it
let's
all up.
believe.
244 bouncy balls.